One of the gaps we need to fill in is the gaps on how to find explicit definitions. We looked at finding recursive definitions in class when we had the explicit already. But if we can't find the explicit definition to start with, as you're given in part 1 of the homework, then we don't even have the ability to start the recursive part. So the key here is to look for patterns other than the ones we've recognized already. And the patterns we've recognized are ones that have to do with addition between numbers, multiplication between numbers, right? And that translates to a particular definition in terms of n. For example, this first sequence we can recognize as being additively recursive. And the idea that we're going to add 4 each time, and we've already talked about how we can find that. We know that the particular definition for this is going to be linear in nature, right? And we were able to say, well, I can find the definition by looking at the slope and then going back one to find the y-intercept. Like, what would the n equals 0 term be? That would be the actual y-intercept if we had a function, as opposed to just coming up with the sequence definition. But it's probably equally important for us to recognize that the other thing going on here is that the differences between the terms, or rather the growth of the sequence, follows a particular pattern. And this idea of the growth of a function is something we talked about back when we were doing parent functions. We said, well, if we can identify the growth, that tells us something. There's something distinctive about how the numbers grow. Right? And here we can see that one level down, all the numbers grow at the same rate. So when we move over to sequence 2, and we look at that set of numbers, initially we check the differences between them and say, well, maybe it's additive between them. But those differences between the numbers, those are not constant. So it is not linear. It doesn't follow the same differences that our first sequence did. Right? So the growth rate, the way that it gets bigger, can't be the same as a linear function. But if we go one more level down, then the growth rate is constant. And so we ask the question, what function has a growth rate that increases at a constant rate? And what is the relationship here between these numbers and the way they are related? And the first one, right? For what type of function is the growth rate linear? And the answer to that, if you remember back, is for a quadratic function, or a polynomial of degree 2. This is going to be quadratic in nature, because the growth rate of the change is constant. For our last one, we look again and we say, well, let's check. 6, and we say, well, that's 18, we got 26, and then 60. And we look at that and we say again, okay, that's once again not linear. And we look at the growth rates again, we get 12. Sorry, this is not 26, but 36. And we get 18, and we get 24. And again, at the second level down, the growth rate is not constant. So this third sequence is not quadratic. But if I go one more level down, I see that the growth rate is constant. Right? So now I'm 3 levels down. This is what we say has 3 levels of difference. And what that levels of difference is referring to, it says, how many levels do I go down before the growth rate becomes consistent? Right? The one before it has 2 levels of difference. And what we should be aware of is these levels of difference are really a way to describe the growth rate of polynomials. When we looked at polynomial parent functions, we realized that polynomials have growth rates that are other polynomials. The rate of change for a quadratic is linear in nature. The rate of change for this third function is going to be quadratic, and so this is going to be a cubic. Right? The form is a cubic. Now that doesn't tell us exactly what the actual explicit definition is, but it does give us a place to start. So at this point, go back into the homework and start that conversation around what do we do once we know the form? What can we do with the terms, the information? Why is it helpful for this cubic to know that one point on the cubic is 1, 2? That alone is not enough information, but a certain set of information is enough to come up with the explicit definition.